On this episode, I'm speaking to George London, who is the Director of Engineering at Survata, where he's heavily involved in solving their data challenges. Today, we'll be talking about what George is working on, the challenges he's facing, his transition from a bachelor's degree in philosophy to his first role in data, applying a data-driven approach to recruiting and the challenges that he saw with that technique and the limitations, and possibly some lessons learned from building out his team at Survata. Thanks for being on the podcast, George.
Happy to be here.
Awesome, man. So I gave a little, quick blurb of being the director of engineering, and that doesn't do you justice. Maybe you can give us a little bit of background of who you are and what you're doing currently.
Sure. So I am, as mentioned, the director of engineering at a startup called Survata. What that means is that I'm responsible for all of the day-to-day people management across the team. I think we have 12 engineers at this point. So I'm responsible for keeping them all kind of well-fed and happy and productive, thinking hard about how the team is structured, how people interact, and kind of how we can set people up for success. I guess in terms of kind of how I got here, it's been a pretty winding road. As mentioned, I got a bachelor's degree in philosophy with a concentration in psychology from Yale. I had no notion at all when I graduated that I was going to end up in tech or tech startups at any point. Ironically, I'm actually from the Bay Area originally. I was born in Berkeley and grew up in Marin and went east for college and kind of liked the area, particularly the New York City area, and thought I was going to stay there for a long time. When I was in college and was facing the prospect of graduating with a philosophy degree, I came to a pretty stark realization that nobody was likely to pay me very much for doing philosophy and that I needed to get an adult job. And it was about 2007 when I had that realization, which was just before the financial crisis. And it was kind of still in the heady days when Wall Street was still really on the upswing. And so that meant it was kind of unfairly easy for me to get an internship at a Wall Street hedge fund, particularly Bridgewater Associates. And so I did an internship there. I liked it. I thought it was really interesting how kind of Bridgewater in particular, their philosophy is that the world economy is a great big machine. And by thinking hard and doing a lot of modeling, you can figure out how the machine works and then use that knowledge to make predictions about the economy and about financial markets. And in hedge funds, if you can make a correct prediction about where a particular financial instrument is going to go in price, then you can make money very directly off that prediction. So there's this really interesting closed loop between understanding how the world works, making predictions, and making money off those predictions. So after the internship, I accepted a full-time job there. And in the meantime, kind of shortly after I went back to school for my senior year, there started being some noticeable cracks in the economy. And then by the time I joined full-time, it was September 1st, 2008, which for any of you who are familiar with the timeline of the financial crisis, Lehman Brothers blew up on September 15th, 2008. So 2 weeks into that job, I got a very interesting firsthand seat into the total collapse of the American financial system from this vantage point inside of a hedge fund. Luckily for me, the hedge fund was short everything in the American economy because they had kind of seen the crisis coming. So I was very lucky to not lose that job because Bridgewater was actually doing pretty well. I stayed there for about 3 years, working a couple places, ending up in their research department, which is the part that's specifically charged with building the models that predict the economy. I did a lot of work on understanding the impact of the Recovery Act, which is the big stimulus package that injected a lot of money into the American economy, and trying to understand if that was working and how well it was working. And that involved a whole lot of looking through government financial records and federal balance sheets and that kind of thing to try to actually track where the money was going and what it was being used for and how that was flowing through into the economy. And that resulted in me getting very deeply familiar with Excel because there is a
gateway drug.
Exactly. There is a lot of modeling to be done and a lot of data to be sought out and cleaned and reconciled and consolidated into these final predictions. And so kind of, although I didn't have any training as a programmer, at least not formally, I had sort of dabbled as a teenager, but never seriously. But it turns out that Excel, if you squint, is actually a functional reactive programming language that can take in data and do arbitrary transformations and produce results, and is not really fundamentally that different from Python or any of these other languages. And kind of what really matters in that context is just thinking hard about the structure of your model and making sure that all the pieces fit together to come to a conclusion that you can actually be confident in. That was very useful training in how to think about a question that can be answered through data, and then how to go through the set of steps that are necessary to actually build a believable conclusion out of that.
Let me ask you a question about that because that's interesting. So in school, so if somebody's listening, the journey, if somebody's listening and going, all right, well, I have no programming background experience, that Excel exposure, understanding the data structure components, understanding that you might have aptitude. What was like the light bulb on moment where you're like, hey, this could be a thing for me? Like, did that just happen, or did you just kind of stumble into the fact that you ended up in a path that was leading more towards, some kind of development?
Yeah, I think it was actually later after that job that I really sort of started to see software engineering as making sense. But, I think the thing that had always driven me to philosophy in the first place was just curiosity about how the world works and about how the pieces fit together, about how society evolves and why. And so, kind of, Bridgewater was, I guess, a transition point from the very sort of ivory tower armchair, let's think a lot abstractly and kind of make predictions based on our intuitions, into actually applying data and having a real concrete methodology that leads to making predictions that are actually much more reliable than what you can get by just sitting down and thinking in a void.
Was there any exposure to any programming there? You mentioned in high school you dabbled in it. Was that the only experience that you had going, through it, the formal education process?
It's actually in middle school, I took my first programming class. I was lucky that my middle school had a computer lab back in the 90s where they kind of tried to teach us C as like 11-year-olds, which kind of didn't really work out that well because our teacher didn't know it that well. And this was search engines were just becoming a thing. Like, I think remember trying to search stuff on Lycos to understand why I was getting, seg faults in C and not kind of getting the answers that I needed as an impatient 11, 12-year-old. Then I took a, pretty long hiatus from formal programming training. I tried taking one mid-level CS class at Yale, but Yale, for a variety of reasons, is still in the Lisp camp. This may have changed in the last decade, but the intro to programming class was taught in Scheme. And at this point in my career, I've done a fair number of programming languages, and I think I have been able to get to proficiency in a number of them. But Lisp likes are still, just for whatever reason, do not agree with the way that my brain thinks about programming. And so, that class was not a success for me.
They made us do Fortran. So I think I'm a bit older than you. So my first exposure to development was in Fortran, and I just didn't take to it. I just disliked it, and it was in college because, like you, in high school they had us do a class, and it was a cluster because same story. Like, I think they're having us learn some basic, and nobody was teaching you the structure, but you had to do something, and half the class was lost. I think one guy had figured something out, and we're all trying to learn from him, and it was just bad. But Fortran was kind of like the realization that, this is not necessarily the best way to teach somebody development. So, just curious, when you were at Yale and you're kind of looking at the courses you took in hindsight, obviously, things are never 2020 when you look back. Would you have actually powered through those CS courses knowing what you know now, or do you kind of look at them and go, you know what, I got, you're a director of engineering at a pretty nice startup, so would you keep the coursework the same, different type of exposure and experience versus having gone through more formal CS training, maybe?
I think in retrospect, I would have gone through the formal CS training. And I do feel that there is a gap there that I have, needed to fill through a lot of kind of self-education. I, have, I guess you probably can't see, but a whole kind of stack of textbooks and things on the bookshelf there of, different subjects that I've used for self-study to fill in some of those gaps. But I do feel kind of even now that there are areas of math and formal computer science that I would like to learn more about.
The one thing that when I talk to people who go through, the different boot camps and programs that are out there, and I talk to a lot of hiring managers, the one thing is always goes back to algorithms and being able to solve for those and handle those in interviews. And that's been the one thing that we've kind of noticed as a consistent trend. Is that something you've noticed from people coming out of like without the CS degree versus the CS degree, that might be just something that somebody going through that program is learning, or is it something that can be picked up through, just your own self-study and education?
I think it certainly is something that can be picked up through self study, but I'd caution that it's hard. It takes dedication and effort and time to pick up. It's not something where you can just, read a Spark Notes guide to algorithms and suddenly pick it up. But, that said, we are very lucky to live in a time when the internet provides us with unlimited learning resources. Like you can literally take MIT's algorithms course online, video recorded for free, full video lectures, and all the homework assignments and exams and all these things. So, it's in a very literal sense possible to get a computer science education for free, but it's something that you have to do for yourself that nobody's going to do for you. And it's, the fact that it's online doesn't mean that it's any faster to do than it would be if you did it in college. And, I wish that I had made better use of the time that I had in college to, be more focused and work harder on things, because as one gets into adult life and has work and competing responsibilities, it just becomes harder, as I'm sure you and everybody knows, to carve out the time for dedicated study and practice of things.
I agree. I think the way I learn now is Audible. I was joking with somebody. I go, if it wasn't for Audible, I probably wouldn't have read a. I air quote reading. I wouldn't have read a book probably in the last like half decade because I can listen much faster than I can read. And but you're right, the educational components out there are pretty amazing. Lots of the boot camps that prepare people to get out. I mean, these are things where if you were making a pivot when you did, these tools weren't there. I guess when you're going fast forward a little bit, so you finished, learning the power of Excel, the gateway drug, and you said a little bit further on, you figured out about software engineering. When was that? Like, what were you actually doing at your job that, the kind of the wheels clicked and you're like, hey, this is a thing that I could do long term?
So I guess kind of what happened after Bridgewater was about 3 years in, I had an idea for a startup that I wanted to pursue. And this was also, 2011, the kind of heyday of TechCrunch and startup fever. And it was literally, a lot of my friends were going off and starting startups. And so I, thought it was a kind of reasonable next step in my career and went off to give that a shot. And as part of trying to turn that idea into reality, I started picking up some basic coding to, put together a proof of concept so that I could show it around and make it more concrete as I was trying to get other people on board. And, I chose Python as that first language. I tried Ruby first, but then I shifted to Python pretty quickly. I think that was a good decision in retrospect. But, after having had the experience of trying Lisp and that really not clicking for me in college, shifting to Python, it just clicked so much more quickly. It was just such a more natural fit for the way that I thought about problem solving. And that it just, it turned out to be remarkably straightforward to just turn the ideas that I had into something that worked on the screen in front of me through Python. It's something I still really love about Python is that it gets out of your way as much as possible. And it's the shortest path between the idea you have in your head and something that works on the screen. And I think that was the point when I started, being able to make a website in Django, which is the Python web framework, and have it take input and save it to a database and put something back on the screen that I realized just, wow, I can actually sit down and just make something with nothing but an idea and a computer. I think that's kind of when the light bulb moment was.
Nice. Yeah, it's interesting. Python, it seems that must be the Swiss Army knife of programming languages. It touches everything from infrastructure to web to data, machine learning. It cuts across. I saw some kind of image that shows where on GitHub the repositories are, Python is, and there's not an area of development that it doesn't cut across. So I think you made a good decision to give that a go and don't recall those Lisp days of trying to figure that stuff out.
There's a joke that Python is the second best programming language for everything.
There you go.
It's pretty true.
That is actually very true. That's too funny. I'm gonna use that as a quote because I think that'd be good for people who are actually on Ruby and are trying to get into Python, which is something we see a lot. And you mentioned you tried Ruby, just out of curiosity. What was it that didn't click? Because we get a lot of people that go, "Oh, I was a Ruby developer, I moved to Python, and it's all good now."
Yeah, so I should actually say that I did like Ruby. In some sense, I still think the syntax and some of the idioms in Ruby are marginally nicer than Python. The thing that was a limitation is the library ecosystem of Ruby. For the startup I was doing, I needed some very basic natural language processing. And so I Googled, natural language processing in Ruby. And the only thing I could find was a sort of very minimally maintained gem that did not seem robust. And then I Googled natural language processing in Python and came up with a library called NLTK, which I think is not kind of a cutting edge popular language modeling system in Python these days, now that we have deep learning. But at the time, it was a very well maintained, robust, deeply featured, kind of academically and open source supported toolkit for doing kind of anything that was within the state of the art in natural language processing at the time. And from there, it turned out that the Python ecosystem is just remarkably good at producing libraries that let you really stand on the shoulders of giants and, just kind of snap together the various Legos that the ecosystem provides. And, particularly when you are working on your own, as I was at the time, it's just so valuable to not have to duplicate any work and to just be very efficient by being able to outsource development to the many very smart people who contribute to the open source ecosystem.
Very interesting. So you went through the startup, learned a lot. So you go to, I assume, get the next job, which would have been your first formal, I guess, role at a company, paid role, not your own startup. What was the interview process like? Because I know a lot of people who have made similar transitions always talk about that first job working for somebody. Obviously, you started gaining some experience, through your own startup, development on your own. Was there any particular challenges trying to get that first role?
So, as part of the last iteration of the startup I was working on, I was doing a lot of work on recommendation systems, particularly for music. And that meant working with Python's kind of recommender toolkit ecosystem, machine learning ecosystem, and particularly pandas, which has become, I think, quite ubiquitous these days, but at the time was still a pretty fledgling library that was mostly used in finance and a few other places. But I had found pandas to be an extremely convenient tool for processing the data that I needed and putting it into the proper format for feeding into the recommendation systems algorithms that I was working on. And so I, through that process became quite deeply familiar with pandas. And one of the things that Survata does is that we run surveys that are used for a variety of things. These days, they're primarily used for measuring the effectiveness of online advertising. But at the time, 4 years ago now, actually almost 4 years ago to the day, my 4-year anniversary was yesterday, the company was primarily using the surveys for more traditional market research. And as part of that, you run a survey and then you do statistical analysis to answer questions like what is the confidence interval around how many people answered yes to this question, or is the way that people answered question 3 independent of or dependent on how they answered question 2? And it turns out that survey data produces very kind of nicely formatted tabular data, and that if you want to do statistical analysis on tabular data, that loading it into a pandas data frame and then using one of the statistical toolkits that the Python ecosystem provides is an extremely natural fit. And so my interview process was basically, the founders of the company said, we want to extend our statistical processing of the survey data. How do you think you might approach that problem? And I said, well, I would load the data into pandas and then load it into these other libraries. And he had never heard of pandas at the time. So he basically said, yes, that seems much easier than the alternatives we were considering. So I think that we should hire you to do that.
Interesting. So you were early on pandas through your own work, which kind of gave you a little bit of insight in terms of how that works. I mean, that might have been the difference maker because obviously you brought a solution to the table that they hadn't even considered.
Pretty much, yeah.
Yeah, interesting. That's an awesome story because you switched from Ruby to Python because there was a particular need. In Python, you found pandas to solve a different particular solution that you were working on your own, obviously your own startup. Was somebody advising you to head down like any of those paths, or were you on your own kind of figuring that stuff out of, hey, this pandas thing, I need to dive in and dig in deeper?
I was figuring it out on my own. I guess I don't think I learned pandas because I thought it was interesting or out of particular curiosity. I learned it because I had a very specific problem that was very difficult to solve without it. And I think that is almost always the easiest and most effective way to learn something is to have a problem for which the thing you want to learn is the proper solution. And then that gives you a very natural motivation to learn how to solve the real problem that you have.
That's cool. I like that. That's an interesting. It all comes full circle. Yeah, and I agree with you. I think having that natural problem to solve means that your drive is there to pick up all those tools you need. And then you mentioned now at Survata, obviously you guys tackle. I know we talked previously about how much data you guys tackle in terms of tracking the advertising exposure and that kind of thing. Maybe talk to us about how all this kind of fits together. So obviously your startup, you have to solve the problem of a recommendation system. You pick up pandas, interview with the founder. You talk about a solution he hadn't observed yet. You get hired. How does all that experience build on itself to kind of end up, where you're at now, I guess, in terms of kind of the projects you've been working on and whatnot?
So I guess an interesting thing about Survata that is maybe a little different from other organizations that have data engineering or data science capabilities is that at a lot of organizations, data science is something that you do to improve your business. Like, you are an online store and you want to see whether or not moving the buttons around is going to increase your conversion rate or something like that. And so you bring in data scientists to enhance a product that's already working. And that, you maybe get data engineers because you need to be able to load all the click data from your store into a data warehouse and then be able to do post hoc analytical queries to see which items are most popular so that you can improve your supply chain logistics or that kind of thing. But kind of in both cases, the data processing and analysis is in sort of a support role to what you might consider the main business. By contrast, at Survata, the data is the business because what clients come to us for is, either historically it was survey data for market research. Currently, it is answers as to whether or not advertising campaigns are working. And in order to answer that question, you have to be very careful about capturing the right data, analyzing the data, using proper statistical methods, and then presenting the data in a way that's flexible enough to answer the questions that people have and that is robust and complete enough to make sure that people are satisfied with the answers that they're getting. And so that means that data processing and data science and analysis and data engineering is extremely core to the entire business of what we do. And the data engineers and data scientists are not in a support role; they're in a primary product development role. And so that meant that when I came in as a data engineer and started off by sort of extending our statistical methodology that was kind of very front and center to the value proposition of the company. And that meant as the company grew, which it did quite quickly and took on a lot more clients, we also needed to bring on more engineers to support those processes. And because kind of I had been early and was very involved in developing a lot of the methods that we relied on, it was just kind of natural that I would lead other people helping on those efforts. And over time, I just got more and more broad exposure to all the different parts of the data pipeline. My background was always in Python and more kind of relatively smaller data, statistically oriented analysis. But Survata also has a substantial big data component because we're processing huge volumes of data about advertising. And so, I was in all the conversations early on in the company about how we were going to design our pipelines and how we were going to ensure the data flowed properly from the top to the bottom of the metaphorical funnel. And at a company like Survata, it all really does have to fit together properly because, if you have problems with how you collect the data, if either your sampling methodology is biased or incomplete, or you just lose data or something because the way that you're intending to collect it isn't robust, then oftentimes there's nothing that can be done about that after the fact. If I'm measuring an event that happened from January through March, and I didn't record the data that I needed from January through March, there's nothing to be done about that after the fact. You're just out of luck. And so that means that in order to successfully and consistently deliver the product, you have to be very thoughtful and very diligent about making sure that the entire system taken together is working the way that you intend it to, and also that it's actually collecting the right types of data to allow you to do the statistical analysis that you ultimately want to do. Because again, if you collect some data, but it turns out to be the wrong data, then there's no way to go back in time and get the data that you realize after the fact that you need. And so kind of my role has ended up being sort of collectively just making sure comprehensively that we were getting the data that we needed, doing the right things with it to keep our clients happy. And then over time, as I took on more management responsibilities, kind of my role has shifted more into helping design and maintain the organization of people who is then responsible for making sure that the whole kind of data product coheres and works successfully.
Just curious, in your current role, when you are faced with a problem that you haven't solved, because I think you've shown a pretty interesting tendency. I guess, how do you go about solving that? Because obviously during your philosophy degree, you mentioned, being curious about the world and problem solving. And then Bridgewater, again, similar, your own startup, you tackle recommendation systems and pick up pandas. I mean, it sounds like that's just who you are. Like if you run into a problem today at Survata, you're just going to keep going at it until you find an answer.
Yeah, I mean, I guess I would say that stubbornness is one of my superpowers, that I'm very willing to stay with a problem for a long time. And, one of the things I like about philosophy is that, you sort of start with the premise that the world is possible to understand. It's mysterious, but it's possible to gain insight into through reflection. And sort of, I find that, you know, particularly with computers, a thing I like a lot about computers is that they are fundamentally understandable. And, particularly in the open source era, you can literally, like if you're running on a Linux computer, you can look at the entire set of code that is producing the output that you see on your screen. And so, assuming that the processor of your computer is behaving as intended, then kind of the entire cause and effect relationship between you pressing a key on your keyboard and something happening on your computer is, at least in principle, transparent to you. And so, if you're willing to really invest yourself in understanding a problem, you can almost always do it. It's just a question of whether or not you have the dedication and patience to really sit with the problem long enough to understand why a problem is happening and kind of what the cause and effect relationship is that produces whatever outcome it is that you're trying to have more of or have less of. And then you can design a system that maximizes your odds of getting the outcome that you want given the resources that you have.
I actually like what you just said. I think your philosophy degree has given you a very interesting outlook on how to solve problems more than anything else. I know before the call, I just want to kind of circle and touch on this because I was just curious. You mentioned data-driven approach. You're obviously a data person, very logical. You apply data-driven philosophies to recruiting, and you mentioned some limitations. So obviously, I'm curious, kind of the limitations you saw, and then being a person that's a problem solver and you're stubborn, how did you go about refactoring and looking at it differently?
Yeah, so I think you can, in a real sense, think about hiring as almost a machine learning problem because the entire point of interviewing and evaluation is to make a prediction as to whether or not a particular person is going to be successful in the particular work environment that you have. And, that's really not fundamentally that different than predicting whether or not a visitor to your website is going to click the checkout button at the end of the day. And so, what you're really doing is looking at a set of input data that you have, which is kind of all of the quote unquote metadata that you know about the person's background, combining that with the data that you can actively solicit through an interview process, and then feeding that into a sort of algorithm that lets you predict whether or not this is a person who you want to have on your team. And there's more to hiring. You still have to convince the person that they actually want to work for you, and you have to find the right people at the top of the funnel to even interview and that kind of thing. But the interviewing process itself is designed to make sure that you are capturing as much useful data as you can. And so in order to do that, you want to, I think, be very intentional about which features you're measuring of people. And to even know what's worth measuring, you have to step back and reflect on what actually makes people successful at your particular company. And, I'm a fairly big believer that different companies are different and different work environments and different problem spaces are different. And so there's no such thing as a globally qualified candidate. There's someone who could, have a really hard time at Survata, but be very successful at some other company. And so we're not just trying to assess some kind of, global quality variable. We're trying to assess a match between our particular set of criteria and the person coming in. And so, in service of doing that, I kind of sat down and thought about what are the particular attributes that make someone successful at Survata. And said, it's things like obviously somebody needs to be able to write code, they need to be able to debug code, they need to be able to think about systems design. But there are also intangibles like they need a baseline curiosity, they need a collaboration orientation because we are a very team focused culture. They need ownership because we're a startup and they need to be able to take a problem and not require close supervision in order to keep moving forward on it. And so I sort of made the scorecard of the key features that people need and then designed our interview process around trying to maximize the amount of information we get about people with respect to those very specific attributes. And then after we do the set of interviews that we do, we ask each of our interviewers to fill out these scorecards that, makes an assessment. Kind of they have a free response where they give their overall impression, but then they also are asked to give a specific data point on the different features that they're supposed to cover in a particular interview. And then in order to make our decision, we get together in a room and we go, instead of like going around the table and saying each person's overall impression, which is what we did before the interview redesign, we now go attribute by attribute. And we say, okay, what evidence do we have that this person can actually write code at the level that we need them to? And then hopefully the people who are in the code writing interview will speak up about how the person did. But if anybody was talking about their career history with them and they mentioned some really impressive coding project or they have some open source thing that somebody became aware of, they can speak up about that attribute. And then we, go down the entire list one by one. And then at the end, once we've surfaced all that data, then we ask people their kind of comprehensive view on, is this person over the bar with respect to what we really need? So that's kind of the conceptual design and the ideal of how we want it to work. And that has resulted in us changing the individual sessions we do in our interview and changing the types of questions that we ask to try to maximize the signal there. The converse of all that is that, we end up learning that it's just very difficult to measure these attributes in any kind of robust way. And there's two reasons for that. One of which is that, problems are just somewhat imprecise, but the other really key reason is time. It's that, in an interview process, a candidate who has a lot of options, who tend to be the candidates who are most attractive to us as well, because they're, people with the track record of success, they may be interviewing at 10 different companies. And so there's a fairly sharp limit on the amount of time that they're willing to invest in an interview process with any one given company. And so, we have something like, between 3 to 6 hours on average of total time that we get to spend with any given candidate. And that's all the time that we get. So, it probably is the case that we could design a, 7-day long rigorous gauntlet process that would give us a very specific and precise perspective on people's coding and debugging abilities, but very few people who we would want to hire would be willing to go through that gauntlet. And so, when you have this time limit, you also end up with kind of unavoidable precision limits on kind of how much confidence you can get on any of these attributes. And then, even if we do end up still heavily factoring what we learn about people into our decision, but then we're still a small enough engineering team that it's not like we have a large holdout test set that we can compare our results against. We only sort of see the results of the people that we hire over time, which both means it takes a very long time for us to see whether or not people end up being successful. And also, we only get data on the people we actually hire. We don't get data on the results of the people who we decline to hire, which means that kind of tuning the algorithm becomes difficult, bordering on impossible. And so, I do think that the process that we have has made us relatively more objective and impartial and has resulted in us making relatively better decisions. But at the same time, it's taught me that I think there is kind of a unavoidable fundamental limit on how much precision anyone can expect from a hiring process, no matter how much effort one puts into optimizing it. And that's, I think a broader takeaway for a lot of data-oriented problems. People often have an ambition that, if I just take a data-driven approach to some problem and I collect data and I analyze it, that I'll be able to get a really reliable outcome and, thoroughly solve a problem. But that turns out to just often not be the case. It turns out that many of the types of problems people want to use data to solve are literally statistically impossible to solve with the quantity of data that people can economically bring to bear on them.
And also, just when you mention it's statistically impossible to solve, and if you could solve it, the barrier to actually get enough throughput through that process might not actually allow you to have the confidence that you could actually hold to. Because I could tell you, we have had clients where they had 3 to 7 day take home tests. And I could tell you that the attrition rate was massive. We'd send out 10, get back maybe 1 or 2. And they had a question of why can't we hire someone? And we said, well, let me explain to you why. So in the case of them, they were trying to actually do what you were mentioning of having that time to confidence correlation, make it easier for them, but no one was finishing the test for them to actually evaluate one candidate to the other. So I think you're 100% right. We see that every day. So data-driven approach you tried didn't obviously work because there's some certain limitations. Candidates with the most options are only going to invest 3 to 6 hours. How much of the process, I'm just curious, when you look at it now, your scorecards, everyone sits around a table. How much of that are you trying to fight now? Any type of just, interview bias? Because you're like, hey, this person sounded good, but do we have enough information on the underpinnings? Because obviously I can talk to you about a project that really sounds awesome and you're like, hey, this person can solve it. But then what are you looking at, at some of the deeper levels to actually prove out, yeah, I think what he said he can deliver?
I think that particular issue is the reason why we design our interview process to involve a mixture of hands-on specific coding work together with discussion, both kind of theoretical discussion and discussion of past projects. It's trying to make sure that we don't lean too heavily on any one signal. So, if somebody can tell a fantastic story about a very complicated project they had done in the past, but then we put them in front of a basic piece of code and ask them to find the bugs, and they can't make any progress on that, then that tells us that there's something missing in the story. One thing I'm actually fairly happy with about our interview process is that with the different sessions we've had, we have disqualified people from hiring solely on the basis of each of the different interview sessions. Meaning, we've had people who were really good at describing their past work, really good at solving an algorithmic problem in a live coding session, but just really bad at working together with our engineers to debug an existing piece of code. Or, conversely, we've had people who were very good at talking about past projects, but then, in a teamwork oriented interview, said things that were very alarming about kind of how they interact with other people, or how they go about building support for their ideas or delivering feedback or that kind of thing. And so I think a well calibrated process will lead to you getting very different information out of each of the different sessions that you do. If you have an extremely high correlation between the sessions, then that means that you're probably effectively wasting some of your time that you have with the candidate and leaving information on the table.
So you came into the industry without the formal CS, degree, Yale philosophy. You had quite an interesting journey through your own startup. Now you hire. I think this question might be interesting from my perspective since you've gone through the process yourself. So now that you're, let's say, looking back on it, is there anything that you wish you knew going into those interviews? Let's say somebody's, gone through a similar path. Let's say you're going through, let's say a boot camp or immersion program. They're going for that first interview. What do you think somebody should bring to the table? You've mentioned a high correlation between talking about a project and what they've delivered. Obviously, they might not have real world work experience yet. What can they bring to the table to help tell that story so that, hey, George looks at them and goes, I can hire you with some confidence?
I should start off by saying that I would caution anybody from learning too much from my own experience, because I think I have benefited tremendously from privilege and luck in my own experience. And, that has resulted in me getting opportunities in my career that probably would be unfairly denied to other people who had kind of superficially similar set of things that they had done with their time. I think for what general advice I can give, it's you only need one job. And I think the most important thing in the job that you get is the match between what you have to bring to the table and what that company really needs. And so, I think getting hired is all about demonstrating that you, in particular, more so than all the other candidates, are the right match for this particular role at this particular time. And so, it's challenging if you're applying to 50 different companies to do any kind of deep research on them and figure out what's relevant. But I think that, to the extent that you can, figure out what you individually are differentially good at and find ways to leverage that into an opportunity that will lead to greater success. And, people who are doing a career transition into software engineering, that presumably means that they had a career before software engineering. And, people may think that's something that they need to shed in order to become a quote unquote regular software engineer. But I think if anything, it's the opposite. Like the experience that you have before you became an engineer is a strength that you should lean on to the extent possible in order to set you up for the next phase of your career. And, if you look at my story, that is very much what happened. The kind of data analysis experience I had at Bridgewater combined with the pandas experience that I had from my startup is really pretty much exactly what made me a fit for the role at Survata. And that is, in a literal sense, I think what caused them to hire me. And so, if you're coming out of a boot camp, I'll be honest, you're facing a lot of competition to get entry level roles. And so you need to think about what you can do to be different from everybody else. And then simultaneously, you need to find the particular company out there out of the tens of thousands of different companies hiring programmers who thinks that thing that you know how to do particularly is particularly cool or useful. And that, trying to invest all your energy in getting hired at Facebook or some company that really almost exclusively recruits out of CS programs at elite schools is probably not going to be the best use of your time. Whereas, finding a startup that is doing something in whatever field your previous job was and demonstrating that, you combine both programming proficiency with domain knowledge in that particular market that startup works in, and that you're kind of willing to accept maybe some non-ideal work conditions that startups often is the best that they can offer. That can be the way to get somebody to take that risk on you. And then if you get that job and then work really hard on developing, yourself and adding value to that startup, then that can be the launch pad into, other types of roles that you might want in the future.
That's great advice, man. That's brilliant because I think a lot of people getting into the industry, making that career switch, a lot of times they try to minimize the past. I've seen that a lot in talking to people, and I think your advice is great because I think whatever problem solving skills you have, as you've mentioned, even though different paths, those skills are fundamental to growing and learning into that first job and beyond. So I think that's awesome. Thanks for being on. I think your journey is very unique. I hope people can learn from kind of the strengths that you leveraged. And obviously, it's difficult to parallel that one to one, but I think a lot of what you've done is transferable to other people. And if somebody has questions about career progress and maybe what they could do, can they reach out to you on LinkedIn? Is that the best format?
Twitter is probably better than LinkedIn overall, but yeah, you can certainly try LinkedIn and I'll answer anybody that I can.
Awesome. We'll put your Twitter in there and make sure people realize that's where they should reach out primarily. Appreciate your time. And we'll be back with another episode of the Data Trek. And please, if you enjoyed the podcast, put a review on your favorite preferred app you're listening to us on. And that'll help us get the word out of what we're trying to accomplish and help people with mentoring and leveling up in their careers. Thanks for being on, George.
Sure thing. Thanks for having me.